A very good day to Dr. Ong Ling. My name is Huang Qi Zen. Today I'm going to present about the body system and the binary tree. Okay, so what is memory management? Memory management is the process of allocating and deallocating memory space in a computer system as programs request and release it. It is an important aspect of operating system design and computer programming, as it enables multiple programs to share the same physical memory and ensures that memory is used efficiently. Memory management is also concerned with ensuring that memory is used efficiently and that the computer's resources are not wasted. This may involve techniques such as memory caching, virtual memory, and garbage collection. Next is the difference between fixed partitioning and dynamic partitioning. In fixed partitioning, the main memory of a system is divided into a number of fixed-size partitions at the time of system configuration, while in dynamic partitioning, the memory of a system is divided into a number of variable-size partitions. In terms of flexibility, fixed partitioning has the disadvantage as the size of the partitions cannot be changed at runtime, while dynamic partitioning has the advantage as it allows for more efficient use of memory by allowing processors to use only the amount of memory they need. Fixed partitioning system is good in simplicity as it is easy to understand and implement, while dynamic partitioning system is more complex to implement and manage. Okay, next is the body system. Now I would like to explain one example of the body system. So now I would like to divide the system into 1024 KB, which is from 0 to 1024 KB. First of all, I would like to divide it half into 512 and 512 KB again for easier use later on. So now first memory A is request for allocate 80 KB into the system. So I would like to divide the 512 into half again, which is 256 and 256 KB. And now actually the 256 is also quite larger for the 80 KB to allocate. So I would like to divide it to half again, which is 128 and 128 KB. And what if I divide the 128 into half again, which is 64 and 64. Now the 64 is smaller than 80 KB, so it cannot be allocated by the memory A. So I would like to use the 128 KB for the memory A to be allocated. So now the red color number, which indicates that this part is being allocated by the memory A. So next is the memory B, which want to allocate 45 into the system. So as you can see here, the 128 is actually quite bigger for the 45. So I would like to divide it into 64 and 64 for the memory B to use one part of the 64 KB. So here it is the figure. And next is the memory C, which is the 70, which it want to allocate 60 KB into the system. So since the 64 KB is smaller than the 70 KB, so I would like to use the another part, which is 256. And again, I would like to divide it into half because 256 is too larger. And now I would like to divide it into 128 and 128, and then one part of 128 is reserved for 70 KB to be used to be allocated. So here is the figure. Next, okay, now the memory A would like to release the 80 KB from the system. You see here the negative sign, which indicates that this memory is going to release the memory from this system. So in this case, I would like to find the part which just now the memory A just allocate the 80 KB into system. Now I would like to release it so that the 128 KB will be available for next process later on. Next is the memory D which request for allocate 50 KB, and now have 128 KB 64 and 128 KB available for this memory, but I would like to suggest that we don't need to use larger memory. We can use the closer 2 to the power m, which is 64. You see 64 is actually enough for memory D to be allocated, so I would like to allocate it into the 64 KB. Yeah. Next is the memory B which requests for release. Again, this is release. So again, I would like to find the part which the memory B is allocated, and now I would like to release it to 64 KB. And next is the release again for the memory D. So for memory D, as usual, I would like to find the part which just now memory D have allocated, and now I would like to release it back again. And now you can see the 128, 64, and 64 is all three blocks are already available for use. And now I would like to add it up to 256 KB. Next is the memory C, which requests for release 70 KB, and as usual, I will find the part which the memory C have allocated the block. Now I would like to release it, and then since the part is already released, so all three blocks are already available. Then I would like to add it up to 512 KB again, and will be available for later on. Okay, next is the binary tree. So before I start with the example of the binary tree, I would like to explain what is binary tree. So in the body system, a binary tree is used to keep track of blocks of memory that have been allocated and deallocated. The binary tree is used to quickly find blocks of memory of the right size to allocate to a requesting program or to deallocate blocks of memory that are no longer needed. So now I would like to explain one example which will be using one row from the previous body system example. And now in this figure I will using three different color for representation, which is white color for root, blue color for available, and red color for occupied. So I would like to start with the top part, which is 1024 kilobytes. So the 1024 kilobytes will be a root node, and it will divided into two children of the root node, which is 512 kilobytes. So in this part, you can see the blue color which represent that it is available for use, and it is pointing downwards to the location, because in this example there is a 512 kilobytes available for use, so the blue color circle will then is pointing downwards. Another one will be roots, and it will divided into the 256 kilobytes. So in this example, there is no 256 kilobytes to be available or to be occupied. So it is two roots, and then it will divided into 128 kilobytes again. So now at the 128 kilobytes, there is two memory to be occupied and one to be available. So in this example, the memory A is occupied with 80 kilobytes and memory C is occupied with 70 kilobytes. So there is two red color circle which pointing downwards to the location, and another one is the blue color which is available for the 1 to 8 kilobytes to be used, and the remaining part is the root node, which will be then divided into two parts of 64 kilobytes. And now at the 64 kilobytes, there is two nodes to be used. One is available, another one is occupied. So in this example, the memory B is to be occupied, so the red color circle is pointing downwards to the location. Then another one is available to be used, which is 64 kilobytes. So this is the overall binary tree example with using one row of the example from the binary system, from the previous binary system. Okay, so that's all from me for the binary system and also the binary system and also the binary tree. And I hope that Prof. Ong can understand what am I presenting. Thank you.